Thank you, Madam Chairperson, Dr. Madiha. So I'm Dr. Wan Hafidz from Hospital Tuanku Jaafar Seremban. So I'm going to talk about Phacodynamics. It's going to be a boring lecture, but don't worry, I'm not going to discuss every detail, just important things to know for beginner. And as you know, basic are extremely important. To be a good surgeon, beside techniques, you also must know your machine as well as your instrument. So this is the common instruction that you hear in OT, right? Increase vacuum, increase bottle height, increase vacuum power. So why do you need to do all this? Is it necessary? Is it a correct things to do? So this is what we're going to discuss. So what is a definition of phacoemulsification? It is where the cataractous lens is emulsified with an ultrasonic handpiece and aspirated from the eye through small incision. Most of the phaco machine that we have will have this general setting for the procedure, which is pre-phaco or sculpting or phaco 1, and then a segment removal, chop or phaco 2, then epinucleus or polish, cortex or irrigation and aspiration, and the last step is visco removal. So you can do all this setting in the phaco machine. There are variety of phaco machine in the market. Basically, each one of it have a foot pedal, phaco machine, the body, and also the handpiece. So this is the diagram of a standard phaco handpiece in every phaco machine. So Dr. Nazra already explained to you all. So I just briefly tell you all about this. So it has a piezoelectric crystal in the body. And then it also has a phaco tip, which is surrounded by sleeve. Okay? And also it contains 3 ports. One is the power cord, which is connected from the body to the phaco probe. And then the aspiration line and also the irrigation line. Then the foot pedal that you all must be familiar with. It is like a foot pedal in a car. You must be able to feel and hear the changes you made during phaco while pressing the foot pedal. Not to see, you only can feel and hear. Okay. So as you can see here, the first is irrigation, means the BSS. The water will come out from the phaco probe and fill in the eye and stabilize the AC. At this stage, if you notice the AC is not too deep, you can lower down. If you notice that the AC is too deep, especially in high myope, in vitrectomized eyes, you can lower down the bottle height and adjust accordingly. Then as you press the pedal deeper, the aspiration will come in where BSS will be aspirated or out from the eye through the phaco probe. Okay, this is where the fluidic balance is very, very important. If you notice the AC is still shallow, you must look at the wound. Is it any leakage? Because sometimes if you use a wrong size color of the sleeve, the phaco sleeve, such as in if you created a 2.75 wound and then you use a 2.2 phaco sleeve, then you will see a lot of leakage from the wound. So you cannot increase the bottle height. It is useless. So you must change the sleeve. But if everything is okay, there's not a lot of leakage from the wound, then you can then increase the bottle height to make the AC deeper. Okay. Then when you press fully the pedal, you will hear the phaco sound. This is where you can start doing phacoemulsification. As I said before, you need to have a good fluidic balance before you start doing phacoemulsification. So this is the 4 dynamic components that you can control during phaco, which are aspiration flow rate, vacuum, ultrasound power, and also bottle height. I'll explain one by one in the next few slides. So what is aspiration flow rate? Basically, it is a withdrawal of fluid and lens matter from the eye. So there's a flow of fluid through the tubing, and it is control the amount of speed at which the fluid is removed from the eye. So what does it do? it attracts material to the tip, and also it determines how fast material is drawn to the Phaco tip. So if you see the lens material come to tip too fast, you can decrease the aspiration flow rate. Then the next is followability, which is a ability to attract material to the tip. Poor followability means that the lens metal doesn't come to the Phaco while pressing the Phaco pedal. So if you see the lens is just floating inside the AC while you're pressing the pedal, you must increase the aspiration rate, not vacuum. Okay, this is the thing that you must understand. Okay. There is a vacuum. There is a common misconception of vacuum among beginners. First, you must know what machine that you use. It is either peristaltic or venturi, which I explain later. In peristaltic machine that we are commonly used in our government OT, vacuum is a negative pressure created to hold the lens material. So what does it do? It holds materials onto the tip. So it only works when the occlusions. Without occlusion, it won't work. This is for peristaltic machine. Higher the vacuum, greater is the holding force. Okay, not higher the vacuum, increase the AFR. Okay, so it's totally different. You must understand this. Vacuum is only work when there's a total occlusion at the Phaco tip. Okay. So occlusion. So you can see this occlusion is obstruction at the Phaco tip. So how does it affect vacuum? In a peristaltic machine, vacuum doesn't build up until tip is occluded. So it is depend on the occlusion. Whereas venturi, which is vacuum-based fluidic, vacuum always present and occlusion independent. So when you have a venturi machine, such as Stellaris, so you no need to have a lens metal to be occluded in the Phaco tip. You can control it by yourself. Okay. So this is the important slide that you must understand. So this is the Phaco. This is a peristaltic pump. Normally, you can see the rotating pump in the machine and the plastic bag where the BSS fluid will be drained into. You can see at the machine. The common one that we use in government is Infinity, Centurion. You can see the plastic bag and also the rotating pump. Okay, rotating wheel. If you press the foot pedal, it will be rotate depending on your aspiration flow rate. The higher the aspiration flow rate you put, the faster it will rotate. Okay, then this is a venturi pump. You can see here, vacuum is controlled by the airflow and it is independent of the aspiration rate, unlike peristaltic pump. It is also can be recognized by presence of rigid cassette and the need to use a compressed air to start working. So you need a compressor gas so that the machine can be start working. So again, with venturi, you can control the vacuum independently and without total occlusion. Okay. So this is the comparison for both peristaltic and venturi. So peristaltic is a flow base, whereas venturi is a vacuum base, and vacuum only created when there's occlusions of the Phaco tip, whereas the venturi in the venturi machine no need to have the occlusion. You can control the vacuum by yourself. Flow is always constant until there's an occlusion when the vacuum start working, whereas in venturi flow varies with the vacuum level, and in a peristaltic machine, the BSA will drain into a soft bag, whereas in venturi, it will have a rigid cassette. Next is surge. Very important things to be aware, especially when you use a high vacuum. So it is caused by fluidic imbalance. It occurs when the aspiration flow rate or vacuum exceeds irrigation. And then it happens when the vacuum that has built up because of occlusion and occlusion suddenly break. Then you can see the chamber instability, the chamber collapse or movement of PC. So this is dangerous when you have surge. So what you have to do? So you must increase the bottle height, decrease your vacuum, and also check for any wound leakage. So if you see this, you must control it. you must put suture. You must create a new Phaco wound. Okay. So bottle height, it's easy to understand the concept. Some new machine like Centurion, they don't have a bottle height. They produce an active infusion by pressing the BSS bag inside the machine, but the concept is still the same. Okay, if you have a deep AC, you can lower down the IOP in Centurion. So basically, bottle height, adjusting the bottle height proportionally adjust the AC depth. The function mainly is to produce adequate IOP to maintain AC despite aspiration outflow, and the higher flow rate require higher bottle height to maintain AC or IOP, and lower bottle height require lower flow rate to prevent AC collapse. So you just adjusting the height of the bottle height. Okay. Okay, now we talk about the ultrasound power of the Phaco handpiece. It is based on the two theories. So jackhammer effect and also cavitation. So no need to know the detail of the mechanism, but the most important, if you see the Phaco tip pushing the lens a lot while grooving in sculpting mode, then you should increase the Phaco power, especially when you are doing a hard Bunderson cataract. Okay, if you doing a sculpting and then you see there's a lot of movement of the lens, then you must increase the Phaco power because it should be a smooth chiseling movement during sculpting. To have you need to have enough power of this ultrasound. The Phaco machine that we normally use also have the torsional movement, which is side-to-side movement, which also have to emulsify the catheter's length. This one I will explain later. Okay, this is also a repetition. Dr. Nazra already explained just now, Phaco tip. Okay, the other important, the most common tip that we use is the Kelman tip. It is a bit bent at the end of the tip. So why we like to use this? Because it helps grooving the nucleus during sculpting. So you don't need to maneuver or move your Phaco probe so much so that it will cause a leakage of BSS from the wound. And then for Phaco tip and needle, the most commonly used is a 45-degree tip. So basically, the more angulation of the Phaco tip, the lesser the holding power, but the cutting is more. Okay. So if you prefer the chop technique, in order to make it easy, you make sure you have a 30-degree tip or less, so that it can hold the lens easily. Okay, sleeve, also a repetition of slide. Dr. Nazar already explained. It is made of silicone, and then it's provide a fluidic pathway for irrigation. It also can prevent wound burn. It has a different color, but when you use this, when you must see the hole where the fluid coming out from the Phaco sleeve. It should be the sideway, not the upside down. Because if you didn't check it properly, sometimes it can cause a wound leak. So once you go inside the eye, you must check that the BSS fluid is coming out correctly. So then what is stroke? So stroke, it is actually how far the Phaco tip move back and forth. This stroke can be modified. For hard nucleus, which need more power, you can increase the percentage of this stroke. So you can increase from 0 to 100%. So for hard Bunderson cataract, you must at least have if you do a sculpting or grooving, you must have at least 70% or 80%. It depends on the density of the nucleus. Whereas frequency is how fast the tip move to and fro. This one is fixed. You cannot modify it. It ranges about 27 to 60 kilohertz. How to reduce Phaco energy? So basically, what you want to do is you try to give less energy during Phaco emulsification so that it won't cause corneal edema, endothelium loss. So how to reduce it? So as a beginner, So you will start with a divide and conquer technique. And soon, later, once you become better, there are many techniques to learn, especially chopping. But generally, we have a stop and chop and also a direct chop. There are many styles, many ways to do a direct chop and also a stop and chop. So, but this is the thing that you need to reduce the Phaco energy during Phaco emulsification. And also you also can learn to adjust the Phaco parameters such as pulse and burst to minimize the Phaco energy. And this setting usually has a default setting in every machine. So this is all things that you can do once you become better. For I think for as a beginner, you can start slow first. You can do and be a safe surgeon. Once you become better, then you can explore. You can use all the setting, all the pulse burst. Okay, what is torsional Phaco? It's basically a side-to-side chopping motion. And then this is to increase efficiency and also to allow better followability. The disadvantage of this is it can cause easily clog. So this torsional Phaco is available in one of the machines that we use in our OT. The traditional Phaco is a longitudinal, which is a jackhammer motion. So this is the add-on beside the longitudinal movement. So I explain briefly the Phaco mode available and pulse mode and also burst mode. So pulse mode where the equal time of power off and on of the Phaco. Later I will show you the diagram. Each shot of ultrasound energy is referred to as a pulse and it reduces the total amount of power delivered compared with the continuous mode. Whereas in burst mode, maximum power delivered at interval which vary with the amount you depress the foot pedal. Energy is fixed, but the frequency will increase depending on the foot pedal. So this is the comparison. Okay? As you pressing the pedal for pulse mode, okay, as you see here, pulse mode, power will be increasing slowly, but the frequency is fixed. Whereas in the burst mode, the Phaco power is fixed, but the frequency is increasing till becoming like continuous Phaco. So this burst mode is actually good for chopping technique. So the purpose of doing a pulse or burst mode is to reduce the power of reduce the energy of others of the ultrasound. Okay, another one is a rise time. It's actually a amount of time required to attain a given level of vacuum, and the speed with which the maximum value of vacuum is reached once the aspiration port is occluded. This rise time is directly related to the aspiration flow rate and also a pump speed. Okay. So as you can see here, in the venturi pump, it has the fastest rise time compared to the peristaltic because it is independent of flow. So venturi machine is faster compared to the peristaltic machine. The rise time is related to the pump design. So how does it imply this rise time? So it is if you have a rapid rise time, you have a less surgical time. Because the machine responds very fast, but the margin of safety is less. So this is the thing that you all don't need to try. For beginner, I think your aim is to do a safe surgery, not to do it fast. Later, once you become expert, and then you can try to do as fast as possible. Okay. So then we go to the step of Phaco emulsification. So just now I already explained briefly the Phacodynamics. What is the important things to know? What is the things that you can adjust? So this is all after this is all the steps of Phaco emulsification. So for sculpting mode, do you need a high vacuum? No, because you just need a low vacuum because you just want to sculpt it. You just want to groove. But you need a high ultrasound if there is a Gundersen cataract. In a soft cataract, you don't need to use a high ultrasound. Bottle height, usually you can start with 70 or 80 centimeter because you don't want the AC is too deep. Okay, this is a general understanding, general setting for sculpting mode. Then you go to the quadrant removal. So for quadrant removal, you need a high vacuum. Okay. So for peristaltic machine, so the vacuum only work when there's a total occlusion. So when you put your Phaco probe onto the lens, and then you see it's totally occluded, then you notice that the vacuum will start rising. Okay. When the vacuum is high, you can hold the lens segment properly. So without vacuum, without total occlusion, you cannot hold the segment. Okay. The ultrasound also must be high so that you can emulsify the segment, and also high bottle height so that you can have a stable AC. You can have a you can get away. You don't want the PC to come near to your Phaco probe because you are using a high vacuum. In epinucleus, you don't need a high vacuum. You just need a low vacuum and low ultrasound because it's just a soft nucleus. Sometimes you don't need to use an ultrasound. You can just use aspiration. The epinucleus will come in. But the bottle height must be maintained at a high position because you want to prevent the PC. You don't want to get the PC. Then you go to the, after removal of the epinucleus, then you go to the cortical removal. So here you change the Phaco probe, you go to the irrigation and aspiration probe. So here you can use a high vacuum, but you must always see the tip of the probe. You don't put the probe facing down because you want to see whatever coming into the IA probe. Okay, the bottle height is depend. If you notice that the AC is too deep, then you can adjust the bottle height accordingly. So as a conclusion, so now we have a lot of new machine. So as technology has evolved, and then also in the next 5 years or 10 years, the complexity of the phacodynamic also changing. But you must understand the concept. So the concept behind the machine setting, so that you know how to adjust it, when to use it. No need to know so detail. You can ask the machine representative to come to explain to you all the basic concept, because our goal is to have a safe and efficient removal of cataract, especially for beginner. Okay, I think that's all my presentation. So it's only 20 minutes. So I think you can ask anything. You can use the chat. You know, you can see there's a chat column, right? So this is better, right? Because I cannot see your face. You can just write it and ask any simple question, okay? Which I can explain. I think until 11:30 I give another 10 more minutes. Okay? So any question you want to ask? No question, everyone understand? Which machine are you preferred? For Phaco emulsification, which is the best? Actually, it's not depending on the machine. It's depending on your technique. So no matter what machine that you have, if you have a good technique, so it will be good. It will be safe in your hands. So technique is very, very important. But I don't know, maybe another 5 to 10 years time, maybe you have a machine that really complex, then can make sure your PC is away from your Phaco probe, the AC is really stable, then it's a different story. But for now, I think the most important is your technique. Basic of machine is the thing that you must know. When to increase the bottle height, the vacuum. I think for government hospital, most of us are using a machine from Alcon. So we tend to use a peristaltic machine. Venturi usually in a private setup. But now we have a Signature Pro, because the machine has a both system. It has a venturi and also a peristaltic pump. Okay, from Ihsan. Hi Ihsan. Assalamualaikum. So how do you change setting when counter configuration like PC LAN? So when you have a PC LAN, so this will come in under my topic tomorrow. So the first thing is don't panic. So the setting that you must know is you try to the I think general concept. If you have a PC LAN, you want to maintain the AC. You don't want the AC is collapsing. So try to lower down everything. Your aspiration flow rate and your bottle height. So you must make it minimum. You must maintain the AC so that the vitreous won't collapse. Okay, so you must stop at your setting and then change to the vitrectomy setting. So basically, you want to lower down everything lah. You want to keep everything minimal. So the most important is to change the bottle. Change the bottle. So usually we put a bottle with we put the BSS with adrenaline. So you must change the bottle, get a new plain BSS, and then put in the lower positions. And then after that, you go to the vitrectomy setting, and then get a bimanual. One in the vitrectomy cutter, the other one is an infusion. So this one I will talk about it tomorrow. Okay, how high or low the bottle should be during each step. This is very subjective. And this is why whenever you put the phaco probe inside the eye, so you notice the AC. So if you think that the AC is very deep, so you can lower down the bottle height. And then if it's central, some of the patient or some of the surgeon, they put until 40 millimeter mercury, as low as that. In there is a centurion. I think for Infinity and other machine, I think to be safe, 60, 70 is the minimal. But if you put the bottle height too low, and then you see the AC is very shallow, then you should increase it. So this is all depend on your patient. Once you put inside, you put the phaco probe inside the eye, then you will notice it. You need to adjust accordingly. Okay, from Xiao Suyi. When learning Phaco, the general Phaco mode is usually continuous mode. When do we change it to pulse or burst? Okay, if you want to try to use a pulse or burst, it should be in a quadrant setting. Okay, during sculpting I think by right you no need to use a continuous mode, and because you need a continuous Phaco. But in the quadrant, if you want to have feel of it, you can change to pulse or burst mode. Then you can feel it, you can familiar with it. Because you don't want the Phaco energy too much for this segment removal, so you can try it. And then it has a default settings. Don't worry, the default setting is the safest one, so you can just press the pulse mode and then you can try it. And then you also can hear the difference. The pulse mode is not like continuous Phaco. You hear like snap, but in the pulse mode it's like a pulse. It's like that. Okay. But you need somebody to stand by. I mean, if you want to try to use other setting as a beginner, and you need somebody that more familiar with the setting. So anything goes wrong, I can can replace it. Okay. Another 5 more minutes. Do you suggest beginner to use continuous irrigation? Okay. Yeah, I think to be safe, because your reflex is not as fast as, I mean, I think it's better to have the fluid coming in without controlling it. So later, once you become better, you can get the on-off button without the continuous irrigation. But I think for a beginner, it's okay to have a continuous irrigation, because sometimes when you panic or you forget, you tend to take off your foot, which cause a AC collapse, which is dangerous. So it's okay to let in the continuous irrigation, so that you have a continuous flow of the fluid, continuous flow of the BSS inside the eye.
Sorry, Hafiz, I have question from my Oni.
My question. Tulis it. My question is, why does during torsional Phaco it always it easily clogged, and how do we prevent it from happening? Thank you.
Okay, if you have a Bullison cataract, this is the common problem. So if you have a Bullison cataract, if you don't have enough power, or maybe if your phaco tip is blunt, this is common problem in government hospital. You can easily get occlusion sound, tat, 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 tat. So this is the thing that we cannot avoid, and we cannot prevent, because we, as a government doctor, we have to deal with all cases, especially the heart and Bullison cataract. So how do you prevent it? So you make sure that the phaco tip, this is what I do. If I see a very Bullison heart cataract, I make sure that the tip is still sharp, the tip is not blunt, because they are using it repetitively. So you just have a look at the tip, see the tip is still sharp. And then the other thing is the IP mode, the IP mode in the Infinity or Centurion. I don't have any financial interest, but this is the machine that they are normally used in government hospital. So you must make sure the IP mode is on. So this IP mode is actually an intelligent phaco. So when there is a occlusion at the phaco tip, especially in heart or Bullison cataract, so there's a program which can cause a sudden increase of power. So this thing can prevent occlusion. So you must look at the IP mode, because some surgeons, they don't like to have that IP mode. But it's actually quite safe. It's quite good program to have when we have a heart and Bullison cataract. Okay. And then the other way to know where is there a safe group depth before we crack? This one will be discussed by the panel after this. I don't know really. So we have a discussion after this, that we can you can listen and ask. Okay, I think that's all. Okay. So I think the question, the other question can be answered by different speaker about the biometry. Okay, that's all. Thank you very much. Okay. From Tashna, satu lagi. What is the normal AFR setting that you usually use? Okay, I think the default setting for AFR is depend on whether you are using sculpting, quadrant removal, right? So basically, the higher the aspiration, the higher the bottle height, you must increase the aspiration flow rate. So let's say you put the bottle height at 100, and the vacuum at 400. So the AFR should be also 40 millimeter, 40 cc per minute, 40 cc, because there's a lot of pressure inside, so you want to get the aspiration fast. So that's why you must increase the aspiration flow rate. So it is directly to the bottle height, and then if you see that the segment doesn't come to the Phaco tip as what you want, when you press the pedal, you also can increase the aspiration flow rate. Okay. Okay. In zonula in zonula dialysis, how do you approach for safe CCC? This one also can be discussed by the next speaker. Okay. Okay lah. So 11:31. I think that's all. Thank you very much. Okay.
Thank you very much, Dr. Wan Muhammad Hafidz, for the very beneficial lecture. We will then proceed to our next talk. Before that, if you have any more questions, you can keep typing the questions using the Slido link that we have given you in the email, and we will continue with the Q&A session at 12:30 o'clock. Okay.